Hey everyone, and welcome back to another episode. Today's topic was suggested by many of you guys, and it is a breakdown of how computers work. I thought this would be a great idea for a video, because not everyone knows how their computer works. In fact, some people just open the box it came in and never look at it again. We're going to go over how each component contributes to the overall function of the machine. This isn't going to be anything super technical. I just want to give you guys an idea of what each component is responsible for. Alright, so let's get started. First up, we've got the brain of the operation, the CPU, also known as the processor. The CPU is probably the most important component in the entire system. Everything it does dictates how fast everything else is going to run. When you give the CPU an instruction, it follows it immediately. If you were to take a snapshot of it in action, it would look like a flurry of motion. The CPU receives data, processes it, and then sends out the results. It can only do one thing at a time, but it does it very, very fast. You might be familiar with the term gigahertz. This is basically how fast the CPU is running. The more powerful the CPU, the higher the frequency. I mean, the more expensive it is. Most people do want to actually need a very high clock speed, since most everyday tasks do want to require it. However, gamers and professionals who regularly put pressure on their computers will benefit from a CPU with a high clock speed. There's also something called cores. These are essentially smaller processors packed inside the main chip. The more cores you have, the more tasks your CPU can work on at once. These days, most CPUs have anywhere from 4 to 12 cores, although some cheaper models still only have 2. And of course, there are some pretty crazy ones out there with up to 24 cores and more. As far as CPUs go, Intel and AMD are the biggest manufacturers. Both offer budget-friendly and premium chips for different types of users. Intel tends to focus on higher clock speeds while AMD focuses on a higher core count. But of course, this changes year by year. Next up is RAM, your computer's short-term memory. RAM stands for Random Access Memory. Its job is to hold data that the computer needs quick access to. For example, any program you have open or any web page you are currently looking at would be held in your RAM in order for your computer to function properly. It needs enough RAM to handle whatever you throw at it. If you have too many programs running, not enough RAM, your computer will start to slow down. Some people call this lagging, and you can usually fix it by closing some programs you aren't using. RAM is volatile, which means it loses its data when the power goes out. That's why saving your work is such an important habit. If you're working on an essay and lose power, you wouldn't want to lose all that work, would you? RAM is measured in the same units as storage, gigabytes and terabytes, but you don't need nearly as much RAM as you do storage. 8 gigabytes should be plenty for most people, but gaming or video editing could require as much as 32 gigabytes or more. Moving on to storage, which is your computer's long-term memory. Unlike RAM, the data stored here is not lost when the power goes out. It's also where your operating system lives. The OS uses the storage to decide what data to send to the RAM. There are two main types of storage, HDDs and SSDs. I already went over these briefly, but the main difference is that HDDs are slower but larger and cheaper. An SSD is faster but smaller and more expensive. It's kind of like the difference between a filing cabinet and a digital vault. Both serve the same purpose, but a digital vault is much easier to access. With an SSD, booting up your computer will take a few seconds. With an HDD, it could take a few minutes. There are other differences as well. For example, SSDs are more resistant to physical shock than HDDs. On average, an SSD will last about 5 years, whereas an HDD will last closer to 10 years. However, many laptops today are starting to use SSDs as their primary storage because the read and write speeds are just so much faster. A few years ago, I paid almost $1,000 for a laptop and it was still using an HDD today. Even budget-friendly models have SSDs. Hopefully soon enough, every computer comes with an SSD by default. Alright, moving on to the backbone of the operation, the motherboard. Pretty much everything connects to the motherboard. The CPU, RAM, GPU storage, even the case itself connects to the motherboard. It's kind of like the manager of the team. It keeps track of everyone and makes sure they're doing their job. One important thing to note is that not all motherboards are created equal. If you buy an Intel CPU, it will only work with an Intel motherboard. Same thing with AMD. The same goes for RAM. The motherboard determines how fast your RAM can run and whether or not you can overclock it. Motherboards also determine how many PCI Express slots you get. These are the ports on the back of your computer. You probably use them for your keyboard, mouse, monitor, speakers, and any external devices you use. It's the motherboard's job to ensure that all the data gets to where it needs to go. It's important to find a motherboard that can support the other components you want to use. UKUNT put a high-performance GPU on a cheap motherboard because it won't have enough bandwidth. Also, motherboards come in different form factors. The largest one is called ATX, and the smallest is called Thin Mini ITX. These are important if you plan on building your own computer in a custom case. Next up is the GPU, the artist of the operation. It takes raw data and turns it into something you can view on your screen. Artists use it to render images. Gamers use it to make games playable. AI researchers use it to train models. Even YouTube uses it to compress videos. The GPU is arguably one of the most important components in a computer. In fact, many new cars now have GPUs because they're used for self-driving. The GPU performs thousands of calculations at once. This is called parallel processing. Essentially, it has a bunch of small processors that work in unison. This allows it to complete complex tasks like rendering a video or playing a AAA title. Many people argue that the GPU is more important than the CPU, and they're not wrong. If you're a gamer, the GPU is definitely the one to upgrade. Of course, both are important, but in the world of AI, it's almost impossible to do anything without a powerful GPU. It's common for people to overlook the GPU, but it's one of the best ways to improve the performance of your computer. The main manufacturers of GPUs are NVIDIA and AMD. The latest models are incredibly expensive, but both companies offer more budget-friendly options as well. It's kind of like buying a car. You don't need the most expensive model. If you're just going to drive around town, it's probably worth getting the cheapest car that can get the job done. The same goes for GPUs. Alright, now let's talk about power. The brain and the artist need electricity to function. That's where the power supply unit comes in. It's the electrician of the team. It makes sure everyone has the juice they need. Power supply units come in different wattages. It's important to get one that can handle the wattage of your graphics card. Otherwise, it won't get enough power and could burn up. Usually, the case you buy comes with a PSU, but you can always upgrade it later. The final thing we need to talk about is cooling. The brain and the artist get pretty hot. It's the cooling system's job to keep them within a safe temperature range. If they get too hot, they could melt down. So it's important to keep them cool. Most computers use fans to move air through them, but some also use heat sinks and even liquid cooling. There are so many different cooling solutions out there. Some people build their own custom loops, while others just stick with stock coolers. It all depends on how much you care about the temperature of your computer. If you're a gamer, it's probably worth investing in a good cooling solution. After all, you don't want your computer to overheat in the middle of a session. Finally, we've got the case itself. This is where everything gets put together. Some people leave their computers stock standard, while others prefer to customize theirs. Either way, the case serves an important purpose. It protects the components inside and keeps them organized. It also helps with cooling and noise reduction. If you're looking to build your own computer, there are a lot of cases to choose from. They come in different sizes and styles. Some are designed for maximum airflow, while others are designed for maximum aesthetics. It all depends on what you're looking for. Well, that's it for this video. I hope you learned something new. If you're new to computers, it can be hard to understand how everything fits together. But once you learn the basics, it's not that difficult. Each component has a job to do. When you understand what those jobs are, it's easier to understand how the whole thing works. Thanks for watching, and I'll see you in the next one.